I hope all of you are doing good. Let's start today's chapter, Basics Geometrical Ideas. And in this chapter, we're going to learn about these topics, right? First, introduction. In our daily life, we come across many shapes such as a round, a triangular, a square, rectangular, etc. Study of geometry is all about study of these shapes and size. The smallest geometrical figure that we have studied is point. Also, we have studied about line, ray, line segment, etc. Let us recall some of these definitions, but first, let's know the history of geometry. It is a Greek word, which geo means earth and metria means measure. Arose as a field dealing with spatial relationships. In Vedic period, the Satpat Brahmana, 19th century BC, contains rules for ritual geometric constructions. The Sulabh Sutras, literally aphorisms of the gods in Vedic Sanskrit, list rules for construction of sacrificial fire altars. Some geometrical figures. First, a point. A point is that geometrical figure which has no dimension. That is, it has no length, no breadth and no thickness. It is just a dot. Not this, but this is a dot, okay? It is just a dot obtained on the paper with the tip of pencil. A point is always denoted by capital letters of the English alphabet. Okay, for example, P, M, N, these are the points, okay? No more, tiny dot which is almost invisible is called a point, okay? The full stop that we use at the end of every sentence in English is also an example of point, right? Next, a line. A line is a geometrical figure having only one dimension, that is length. A line has only length, no breadth and no thickness. It is represented as AB. Okay, this is the symbol for line, right, and is read as line AB. A line can be extended indefinitely in both the directions. That is, it has no fixed length and it is indicated by arrows on both the sides. Okay. Sometimes a line is also represented by small letters of the English alphabet as line L and M. No more. A line has infinite points on it. Number 2, through one point, infinite lines can be drawn. Number 3, through 2 points, only one line can pass, right? Next, a line segment. A line segment is the part of a line having fixed length and fixed end points. A line segment is named by its end points. In figure 4.3, 1 and 2, as you can see here, it is denoted by AB. This is the line segment, okay, and there are no arrows as you can see, and PQ, and it is read as line segment AB and line segment PQ. It is important to note that there is no arrow in line segment, which shows that its length is fixed and it can't be extended further in any direction, okay. Next, a ray. A ray is a part of a line which has only one end point and it can be extended indefinitely in other direction. In figure 4.4 part 1, ray is denoted as OA and read as ray OA, okay, OA. This is the symbol for ray. Here OA is called the initial point. This is the initial point of the ray. In figure 4.5, 1 and 2 ray OA can be extended indefinitely along A, and in ray PQP is the initial point and it can be extended indefinitely along Q. So, this ray from A we can extend it indefinitely in this side, and in ray PQ also we can extend this from Q, okay. A plane. A plane is a flat surface that extends indefinitely in all directions. The blackboard in your class, the tabletop or walls of the room are all examples of plane. Remember, the plane means whole surface, and whole surface cannot be shown on a sheet of paper. Usually, we represent a plane by a parallelogram or a rectangular. In figures 4.5, 1 and 2 below, there are two portions of the plane. Here you can see, okay. Let's do exercise 4.1, fill in the blanks. A ray has dash endpoints. How many endpoints does a ray have? Okay, it has only one endpoint. A ray can be extended indefinitely in one direction. Okay. Parallel lines. Look at the blackboard in your class and observe its edges contained in length and breadth as given in figure 4.6. Now extend the edges AB and DC. AB and DC in both the direction. Okay, see AB, okay, like this. This is AB and this is CD. Extend in both the direction and this also. Okay, do they meet each other? No, even if you extend them endlessly, they will not meet each other. They are called parallel lines. Actually, parallel lines never meet each other. Okay, look at the opposite edges of your scale ruler. They also do not intersect. They are also example of parallel lines. Railway lines are another example. Okay, math extension. Sometimes we say that parallel lines intersect at infinity. That is, they never intersect, never and ever. Okay, lines which never meet each other, however long we extend them, are called parallel lines. In other words, the distance between two parallel lines at each and every point is same. Okay, next is concurrent lines. Look at the lines given in figure 4.8, which pass through a common point. See, it passes through common point O. Okay, how many more such lines can be drawn through this point? We can see infinite such lines can be drawn passing through the point. All those lines passing through a common point are called concurrent lines. Thus, in figure 4.8, L, M, N and P are concurrent lines. It is to be remembered that two lines either are parallel to each other or they will intersect each other. Two lines always intersect each other in one point only. We can think about the letter X of English alphabet, a Caesar. All these give the idea of intersecting lines. See, this is alphabet X and these two lines are intersecting lines, right? And in scissors also. Okay. Polygons. Poly means many. Polygon means figure bounded by many sides. Look at the figures given below. All these figures are closed figure, if you look them carefully. Here, except for, that is circle, all are polygons. A polygon is a closed curve bounded by a number of line segments. This figure is an example of polygon bounded by 5 line segments, namely, see, AB, BC, CD and AE. Here the corner points like A, B, C, D, E are called the vertices of the polygon. A line segment joining any two opposite vertices is called diagonal of the polygon. Thus, BD, okay, BD and BE, then AC, AD and CE are the diagonals of this polygon. Two sides of a polygon with common endpoint are called adjacent sides, right? Now, curves. When we trace a figure on a paper without lifting a sharp edge pencil, we get a curve. Curves are of two types. A, open curves, B, closed curve. Open curves. When curves begin and end at different points are called open curves. For example, this one and this one. These are open curves. Closed curve, when curves begin and end at the same point are called closed curve. Now, rest of the curves are closed curve. So, curve 1, 3, 4 and 6 are called closed curves because they begin and end at the same point, and these are called simple closed curve. Curves 2nd and 5th are called open curves. Example 1, classify the following curves as open or closed. Okay. So, this is closed, open and these are also closed, right? Exterior and interior of simple closed curves. A simple closed figure separates a plane into 3 parts. Interior, the part which is inside the curve. Exterior, the part which is outside the curve, and the figure itself. See a simple closed curve given below. Okay. See, these are the interior points. Okay. This is the exterior point and this is also exterior point, and these points are on the curve, right? So in this figure, the points M and B are in the interior of figure. The points X, Y, Z. Okay, Z also is outside this figure, so it is also the exterior of the figure. And the points L, A and O lie on the boundary of the figure. Hence, the closed figure is divided into 3 non-common or disjoint parts. Right? See these curves. See, this is the shaded portion. The shaded portion is interior of curve, that is inside the curve. Shaded portion is exterior of the curve and the boundary of the curve. Okay, no more. The interior of a curve together with its boundary is called its region. Okay, now let's do exercise 4.2. Fill in the blanks. Number 1, two lines which do not intersect are, which two lines do not intersect? These are parallel lines. Okay, they never intersect each other. Now, angles. Angles formed by rays. If we mark a point O on the sheet of paper and draw two rays, that is OA and OB originating from O as shown in the figures given below, they form an angle. See, these are the angle formed by these two rays. Remember, rays OA, OB cannot be written as AO or BO. In rays, a first initial point should be written. Okay. See, this is the ray OA and OB, and we cannot write them as BO and AO. Okay, this is wrong, right? An angle is formed by two rays having a common initial point. See, these two rays do not have any common initial point, so these figures do not represent angle as their initial points are different. Okay, no more. If rays are extended in figure 14.17 part 2 to meet each other at a point that takes an initial point, then angle can be formed here. Angle ACB is formed by rays CB and CA. Okay, if we extend this point, then it will make an angle. Okay, so now next, vertex and arms of the angle. The common point of the two rays forming an angle is called the vertex, and the two rays forming the angles are called the arms of the angle. Thus, in figure 4.18, O, this is the vertex and these are the arms. Okay, OA and OB, these are the arms. Okay, no more. Number 1, the given angle in figure 4.18, that is this, is written as angle AOB. Remember, the vertex is always written in the middle out of 3 alphabets used for an angle. This angle can also be written as angle O. Number 2, it is wrong to write the angle O as angle BAO. This is wrong because O is not in the middle. Okay, or if you write as angle ABO, this is also wrong because O point is not at the middle, right? Example 2, name the angle in the given figure. Okay, so these are the 4 vertices. Okay, so angle A, angle B, angle C and angle D. These are the 4 angles, or you can also write like angle ABC, angle ADC, angle DCB, angle DAB, right? Now let's talk about a triangle. A triangle is a simple closed curve formed by 3 line segments. We can also say that a triangle is a polygon containing 3 sides. Parts of a triangle. In figure 4.23, a triangle is shown. It can be named as triangle ABC, triangle BCA or triangle CAB, and this symbol, you know very well that this is the symbol for a triangle. Okay, this symbol represents the triangle. Thus, the triangle given above can be written as triangle ABC. Line segments AB, BC and AC are called the sides of the triangle. See, these are the sides AB, AC and BC. Right, whereas A, B and C, these are the vertices of triangle ABC. Also, a triangle has 3 angles. In triangle ABC, the 3 angles are angle A, angle B and angle C. Or you can say angle ABC and angle ACB or angle BEC. There's 3 sides, that is AB, BC and AC, and angle A, angle B and angle C are called the parts of a triangle or the elements of a triangle. Okay. On the basis of sides, a triangle can be classified in 3 ways. Number 1, scalene triangle. A triangle in which all the three sides are unequal is called a scalene triangle. For example, this is a triangle, 2 centimeter, this side is 4 centimeter, this side is 3 centimeters. So all the three sides are unequal, so this is scalene triangle. Number 2, isosceles triangle. A triangle in which two of its sides are equal is called isosceles triangle. Though figure are given on the next page, but I am telling you here, okay. See, isosceles triangle has two equal sides. And number 3 is equilateral triangle in which all three sides are equal, means this, this and this, all three sides are equal. No more. Sometimes equilateral triangle is also called equiangular triangle also, okay. See, this is the scalene triangle, isosceles and equilateral triangle, okay. Now, quadrilaterals. A quadrilateral is a simple closed curve bounded by 4 line segments, or a quadrilateral is a polygon bounded by 4 line segments. The following figure, that is this figure 4.25, represents quadrilateral ABCD. In the quadrilateral ABCD, 4 points, that is A, B, C, D are called its vertices. 4 vertices are there, okay. Line segment AB, BC, CD and AD are called sides of the quadrilateral. It has 4 angles, namely angle A, or you can say angle BAD, angle B or angle ABC, angle C or angle BCD, and angle D or ADC, okay. The line segments joining its opposite vertices, that is A and C and B and D, are called diagonals of the quadrilateral. Thus, AC, okay, let me show this with another color. Okay, so AC and BD, these are what? These are the 2 diagonals of the quadrilateral of a quadrilateral ABCD. Okay, since AB and DC, which have no common vertex, are called opposite sides of the quadrilateral ABCD. Similarly, AD and BC are also pair of opposite sides. Angle A and C, which have no common sides, are called opposite angles. See, angle A and angle C, these are opposite angles. Similarly, angle B and angle D are also opposite angles, right? Because they do not have common sides. Now, angle A and angle B, which have common sides, A, B, are called adjacent angles. Now, let's talk about angle A and B. Okay. So, have a look here. Angle A and angle B, okay, these have common sides AB, so these are called adjacent angles. In the similar way, angle B and angle C, these are adjacent angles because they have common side, that is BC, okay. And angle C and angle D, angle C, angle D and angle A and angle D are form pairs of adjacent angles because common sides for them are BC, CD and AD respectively, okay. Remember, it is important to note that a quadrilateral is always named clockwise or anti-clockwise. Thus, the quadrilateral given alongside can be read as PQRS or PSRQ, but it is wrong to read it as PQSR, okay, or PSQR. This is wrong. Diagonals. The line segments are called diagonals of quadrilaterals, which are formed by joining opposite vertices of a quadrilateral. So, a quadrilateral has 2 diagonals. See, quadrilateral means a figure which has 4 sides, right? So, these lines are called diagonals, okay. A quadrilateral divides the surface of the paper into 3 parts, that is the interior, the exterior and the quadrilateral itself. In figure 4.27, the points U and T are the interior of quadrilateral ABCD, okay. Next, the point PQRL, okay. Where are the PQRL? These are the exterior of quadrilateral ABCD, okay. This is P, this is Q, this is RL, exterior points of quadrilateral ABCD. And the points, rest of the points, that is V, S, A, B, C and D lie on the quadrilateral ABCD, right? In example 6, you have to draw a rough sketch of a triangle that is ABC. You will name it as ABC, okay? And then mark a point P on its interior. Okay, so we will use different P, interior, and a point Q in its exterior, okay? Point Q, exterior. Is the point A in its exterior or in its interior? Can you say where it is? Actually, it is neither in the interior nor exterior of triangle ABC. It is on the triangle ABC, right? No more. Why the huge structures like electric tower are made triangular in shape but not the quadrilateral? Reason is triangular shape is rigid. Okay, remember that. Let's do exercise 4.3. Name the angles given below in all possible ways. Okay, so in figure 1, this you can say angle O or angle AOB, or you can say angle BOA, right? Circles. A bangle, a coin, a ring, a wheel are examples of circular shape. A circle is a simple closed curve in which every point is at the same distance from a fixed position. This fixed point is called center of the circle. The fixed distance is called the radius of the circle. A circle can be drawn using a pair of compasses. We keep the needle like pointed and fixed and rotate the pencil fixed at the other end. The fixed point where we place needle-like pointed end is called the center of the circle. The distance between the needle-like point and the pencil end, which is kept fixed to draw a circle, is called the radius of the circle. Circumference of the circle. The closed boundary of the circle is called circumference of the circle. Okay, see, this is the closed boundary. This is known as circumference. Okay, this is the center and this is radius. Okay, and diameter, this is diameter, this is also diameter, and these diameters are called also. Okay, a line segment passing through the center of the circle with two endpoints on the boundary or the circumference of circle is called the diameter of the circle. In the above figure, that is figure 4.32, AB and CD represent two diameters of the circle. Okay, see, AB and CD, these are the two diameters of the circle. Can you say how many diameters can be drawn in a circle? Many. How many lines can be drawn passing through a given point? Of course, infinite. Okay. In a similar way, through the center of the circle, infinite line segments can be drawn with their endpoints on the circumference of the circle. Thus, infinite diameters can be drawn in a circle. Remember that. Next, chords of a circle. A line segment with its two endpoints lying on the circumference of the circle is called chord of the circle. In figure 4.33, right, many chords, that is A, B, C, D, E, F, P, Q and R are shown. In a circle, infinite chords can be drawn. Again, we can draw infinite chords on a circle. Okay. Next is arc. Any part of the boundary of a circle is called arc of the circle. In figure 4.34, first part, PQR. See, PQR, this is the arc. Okay, and QRT. Okay, let me show you. QRT, this is also arc, right? And XTR. XTR also represent what? XTR, this also represent, these are the arc of the circle. 2 points P and R on the circle divided into two parts, namely PQR and PXR or PTR. Okay, this is the symbol or sign for arc. Okay, one is a small and other is bigger. The smaller are called minor arc, okay, of the circle, and the larger arc is called major arc of the circle. In figure 4.341, PQR is minor arc. See, PQR, this is minor arc, whereas PXR is a major arc of the circle. If the circumference of the circle is divided exactly into two equal parts, two equal arcs, then they are called semicircles. Okay, see, circle, and let's divide it into two equal parts. Okay. In figure 4.34, ACB, arc ACB, this arc, okay, and the arc ADB are two semicircles of the circle. Okay, now sector and segment of a circle. Well, a semicircle also means half of the circle, right? Now, sector and segment of a circle. Consider a circle with center O and mark any of its chord as, say, PQ. Okay. We see that chord PQ divides a circle in two circular regions which are called segments of the circle. Okay. See, this is your circle and this is the chord PQ. Now, this chord is dividing circle into two segments. Okay. The smaller part is called minor segment and bigger part is called major segment of the circle. See, this is the minor segment and this is the major segment. Right? No more. If PQ line segment is extended up to infinity, then PQ is called secant. Difference between secant and chord is secant is a line correspond to the chord, which is line segment. Okay. If we extend this line, then it will become secant. And the difference between secant and chord is secant is a line. Okay. And we can extend it infinitely. Whereas chord is a line segment. Right? Sector of a circle. The part of a circle bounded by two radii and an arc of a circle is called the sector of the circle. See, this is the sector, minor sector, and this is major sector. Okay. In figure 4.36, the shaded or smaller sector is called minor sector of the circle and the bigger part is called the major sector of the circle. A diameter of the circle divides it into sectors which are equal and called semicircle. No more. Number 1, radii is the plural of radius. Number 2, distance around the circle in its circumference. And number 3, region in the interior of circle enclosed by chord is segment. Right? Now, let's do exercise 4.4. Number 1, draw a circle of radius 4 cm. Mark its center as O, one radius OP, one chord and one diameter. Okay. So, you with the help of compass, you will draw a circle. Okay. Its radius of 4 cm. Its center is O. Okay. One radius, that is OP, and this is of 4 cm. One chord, you can draw anywhere, any chord A, B, and you can name it whatever you want to name it. Right, students? Now, you will do practice of the remaining questions by yourself.